Hello everyone. Welcome to the March online ContinualAI meetup, where this is actually really special to ContinualAI because we can talk about a project that we've been working on for over a year now. And it's something that, by the way, I'm Keiland. I'm one of the co-founders and board members of ContinualAI. And it's something that I know is going to be really near and dear to Vincenzo, who I'm going to introduce in a second, and a lot of the other parts of the team, and something that I never really dreamed would be possible from an organization like this, kind of in a pipe dream. But in only 2 years of being an organization, we now have actually developed tools that can really push the field forward and can take someone who just wants to start out doing continual AI and only like a small script to be doing actually cutting edge research and not have to worry about all the intricacies of implementing a new algorithm from scratch or loading in data. And you'll see all of this as we go through each of the aspects that are going to be introduced by the lead maintainers. And so I'm really, really excited that we get to share this. And I'm excited to introduce Vincenzo Lomonaco, the president of Continual AI and a new minted professor at the University of Pisa. So congratulations on that. And we can have you tell us all about the background. After you unmute yourself.
Oops. Yeah, thank you so much, Keiland, for your great introduction. I'm going to try to share my screen now so that we can start the actual presentation. Right. Okay, you should be able to see my screen and hear me well. Do you?
Yes.
Okay, cool. All right, so I have somehow the honor to introduce to all the Continual AI community now this tool, which is Avalanche, an end-to-end library for continual learning. I'm gonna just have like a 10 minutes introduction on how the project came to be and what are, let's say, its main objectives, and what's the main modules that defines it in code as well. And then I will let the other main maintainers to somehow introduce each of those modules, each of those parts of Avalanche in more details. Avalanche is and wants to be an end-to-end continual learning library based on PyTorch. So the idea is to have a single code base which is useful for the whole research topic of continual learning. And it has the unique goal of providing like a collaborative and community-driven open source code base for fast prototyping, training, and reproducible evaluation of continual learning algorithms. And something that I really want to stress here is that we wanted to make this tool like a real community-driven project by making it like a project spinning from Continual AI, which is a democratic research organization, and is based on the and then direct, let's say, from the people that are part of it. So the having such a tool copyrighted by Continual AI and MIT licensed and guarantee the whole community to have this community-driven and collaborative code base, that is subject essentially to the will and the desires, the needs of the community itself, not just of an handful of people, right? So this guarantees also continuity to the tool, because it's something that when me or Lorenzo and other people within the Avalanche team, we leave this platform, all the code and the code base will continue to progress for the good of the research community. And essentially, Avalanche can provide like a unique access point for continual learning researchers and practitioners, and can help them essentially write less code, prototype faster, and reduce errors they put into their code, of course, reduce the complexity of the research, let's say, and development experience. It's very useful to improve reproducibility because it has somehow all the pieces that are important for reproducing and port your algorithms to other settings. And it may also improve modularity and reusability of something that you write within the platform itself. And the last 2 points that I wanted to mention here is the increase in terms of code efficiency, scalability, and portability, because now you can take all, given that we already made all the, let's say, efficiency and scalability and portability reasoning behind the tool, now you can use it transparently just by writing on top of what it's already existing and offloading somehow, outsourcing the efficiency and scalability effort to Avalanche. The last interesting point that I wanted to make is that also this unique platform for continual learning research can help us also augment the research impact and usability of our own research products. So in the ideal and in the vision of this tool, when you develop a new algorithm, a new benchmark, you just write a pull request to Avalanche, and then as soon as the paper is out and you want to publish your code, you just see integrated into Avalanche your new solution, your continual learning solution, and other people may use it and cite even your work. So what about the, let's say, organization of the project? So as I mentioned, this wanted to be like a very broad effort. At the same time, we couldn't like have, as we tried in the past, to have a project which is starting directly, right, as a community endeavor. So we started just by providing an API and something that we trust it's a very good starting point. But now we are very interested in having more contributors, more people joining the effort, maybe integrating even other similar endeavors within our community and try to shape what we have today in what could be like a truly community-driven project. And at the moment, we have 5 main maintainers, myself, Lorenzo Pellegrini, Andrea Cossu, and Antonio Carta, and Gabriele Graffieti, who truly believed in the project from the start and pushed a lot to make it happen, and so thanks to them especially. Just a couple of numbers here. We have already like 40 plus contributors to the code base, and I think that somehow many of the continual learning stakeholders around the world has already joined somehow the effort or are willing to support the effort. And we count already 15 plus organizations and leading CL labs across Europe, USA, and China. Of course, ContinualAI will support with his own research consortium of continual learning labs the development of Avalanche as like the central building block for a renewed, let's say, an integrated collaboration among labs in continual learning around the world. And yeah, so we already started integrating different code base like Facile, which is like a nice code base developed by Mark Mazzana and colleagues working on class incremental learning. And this is gonna soon be integrated into Avalanche. And we have like huge sponsors on the way that are gonna somehow help us fuel the progress in the development. So what are the main design principles of Avalanche? Well, they are like loosely connected to the advantages that I talked about in the first slide, but I wanted just to put them here just to stress them out a little bit more. So the idea of comprehensiveness and consistency. So the idea of not having like separate tools for continual learning that have to be integrated and they need to interoperate among each other, but just to have just one code base which is very, very consistent and easy to use, because it's all be designed to interact. I mean, all the modules that are composing it are designed to interact already among each other. And also, I think that the comprehensiveness approach to have just one code base, it's useful because you have like a single access point to whatever you want to do within the continual learning landscape. And So yeah, the second major point is the ability to use the tool in an easy way, and the other maintainers know that I stress a lot on this point every time we write the same code all over again, because we need to be easy to explore. I mean, the tool needs to be easy to use, easy to learn, and to digest in all its complexity. And yeah, another important point is that we don't want to provide like complex hierarchical classifications of nomenclature and settings, and tell the user how should be using the platform. But the idea of Avalanche is to instead to provide the basic building blocks, the basic utilities, so that you can do whatever you want with your own original assumptions, solutions, algorithms, and so on and so forth in your paper. So this is, I think, very important. It's like a Python style approach to the problem. We want to be easy to use, simple, and not provide any constraint to people that want to think outside the box. And also, we want to change fast, as the continual learning community is changing, in fact. Then a couple of important, but I will say more like easy to contextualize within any coding project is the idea of being able to reproduce and to port solutions across operating system, different Python versions, different hardware, and so on and so forth. And the idea of being very modular and somehow independent. So if you want to use part of Avalanche without using the rest of it, you should be able to do it. And this is what we have always thought would be important to reduce the complexity of learning about the tool, and also use part that are interesting to your project, and just them, not needing to go through the whole complexity of the system if you don't need it. And finally, the idea of being community driven. So the idea that we want to support first what's needed by the majority of the continual learning community. And this is why you can see now in the code base, like there's a huge support, a strong support for computer vision and supervised learning, but that's only because more than, I think, 80% of the works that have been carried out within this community in the last few years and within the deep learning landscape, they have been done in the context of supervised computer vision scenarios. So the idea is to integrate next what people want more, and also to move slowly. So we don't want to include everything in a matter of a few weeks. We want instead to provide like something that is solid, and we're working towards the beta release soon, so that people can actually use the tool without like delving too much into the internals of the code or all the bugs that you may find if you accelerate too much this process as well. So yes, I don't want to steal much more time, but just a couple of slides more. So this is Avalanche in a nutshell, and I think this is very important to see before the actual talks from the other maintainers who are going to talk essentially about the different modules they are maintaining, that you can see here in the top row of this image. So Avalanche is at the moment is composed by these 5 different modules. So benchmarks, training, models, evaluation, and logging. And here at the bottom of this slide, you can see essentially what we call experiences, just not to use the overused tasks or batch words. So you have an experience which is just a batch of data, just a couple of examples. And these, and you see, you encounter a stream of those experiences that you can access just one at a time. In this case, for example, the EI experience, the current experience you are processing. And you can generate this stream of experiences with an instance, let's say, of the benchmark. So these dashed lines indicate like objects that you can instantiate from the actual modules libraries. And essentially what you have here is in ICL, like a continual learning algorithm that essentially process the learning experience E of I, and updates essentially its internal model, ham, accordingly, or maybe even its data structures like the memory replay buffer, something like that. But well, this happens within the continual learning algorithm, which is also, let's say, interface with an evaluator, which is an object in charge of the evaluation process, who has these different metrics inside it, P1 to PM, and also let's say refer to the loggers, different loggers you may have, like TensorBoard, dashboard, as std out, yes, logger, or maybe even a file that are essentially delegated with respect to how to essentially publish metrics results. So essentially, within this framework, we, I think, are able to put almost anything that has been proposed in continual learning, which is, the framework is very general and can somehow put together all these different very important aspects of continual learning experiment, which is handling the data, handling the training, and handling the evaluation and logging part. That should somehow be, related in an useful way, and should be able to interact swiftly among each other. So just to conclude, I think, yes, then I can let Lorenzo introduce the benchmarks module. Here you can see some key links, I think, for the Avalanche official, for the Avalanche project. We have here the Avalanche official website, avalanche.continualai.org. Then the GitHub, the Avalanche AP doc for more details about the actual code and classes and modules. And we have also, of course, the Avalanche Slack channel within the ContinualAI workspace. And yes, maybe I can just show you very quickly the Avalanche official website. You will find here, useful examples, but also like long tutorials that you can easily run on Colab. And but essentially, what I want to show here is how, for example, this example of creating like a simple MLP-based experiment running on permuted MNIST is when starting from scratch and trying to use just PyTorch, and how using Avalanche you can just squeeze all that complex script into a few lines of code. And I think this is impressive, especially considering what you could do, like monitoring the experiments directly on TensorBoard, having access to all the metrics in a simple dictionary, having all the pre-trained models ready. A lot of interesting features that it's I think even hard to convey in this talk and also in the documentation here. But I hope you will find the time to explore a bit this tool. And thank you so much for your attention.
Awesome. Thank you. And if anybody doesn't want to type in the link, I threw them in the chat. So you can just go through and click and look at the GitHub repo. You can look at the official website or read some of the APIs later on. But first, we'll dive deeper into the different components of Avalanche in the next couple sections that we have here. And so next, to introduce the first, so we'll do these in order, basically, as you're writing your, say, a continual algorithm program in Avalanche. What do you start with? You start with your data. And usually you'd have to go through and find your different data sets and download them if you don't have them already. But really, the benchmarks model of Avalanche should, first off, it's standalone. So even if you just want to use it for your data, you can. But it's so much more to that. And to tell you all about it will be Lorenzo Pellegrini from the University of Bologna.
Hello everyone.
Hello.
Yeah, I'll just thank you, Keiland, for introducing me. I'll just share my screen here.
Yeah.
Perfect. Nice. Hi there, everyone. My name is Lorenzo Pellegrini. I'm the lead maintainer for the benchmarks module. Well, this is the first module you usually encounter when you first start to approach Avalanche. Is the module in charge of the creation of the benchmark, the data loading process, and in general, it's the module in charge of the whole data part. So without further ado, I think we can move and see what this module is really about. So the first thing about this module is that it's pretty much standalone. It means that you can adapt it, you can use it in your project without having to use other other Avalanche modules. It's kind of standalone because, of course, when you start creating your experiment, the first thing is probably the data. Is the data flow that you will have to handle that will then be passed to your strategies and so on. So this module is kind of standalone, very simple to use. It's very simple to use many of the out-of-the-box tools and benchmarks which are already implemented in there. Is very flexible, and it will allow you to implement all your custom benchmarks, every benchmark you may already have or you want to implement, and to port it into Avalanche. So the main role is to save time, save a lot of time of researchers that are reinventing the wheel by writing a lot of code to create a data stream and so on, or by importing external code from papers that define different benchmarks. So the role is to save your time with a very simple to use module and interface. And as I said before, one of the main, let's say, good part of this tool is to have many different out-of-the-box tools to use, to adopt, to use in your experiment a huge number of benchmarks. So the benchmark module takes care of the data loading procedure, and for many datasets we have an automatic download system. It has a data generation system that will allow you to create out of one or more data sets a stream of experiences, the experiences that your strategy, your continual learning algorithm will have to process to improve the internal knowledge. And of course, many of those benchmarks are already out of the box, like a split and nest, Cypher, but even more complex benchmarks like the one based on Stream 51, the one based on Core 50, and the amount of classic benchmarks is ever growing, so we are expanding it continually. And of course, there are a lot of tools that will allow you to implement your custom benchmark, even if it's a complex benchmark, non-standard benchmark, or very strange things, you can implement it, and we give a lot of support for torch vision datasets, but generally every kind of possible way to define a continual learning benchmark. So the very first approach to Avalanche is to use a very simple classic benchmark. Probably is the most classic simple benchmark you probably see in continual learning literature in split and nest. And this is a classic benchmark. So there are many of those for Cypher, ImageNet, and so on. And they are very easy to configure. There are a lot of configuration options, and in one line of code here in 3 lines because of space, you can create a very simple split and nest benchmark instance. For instance, we will define 5 experiences, which means that we'll split the original data set in experiences, each containing 2 classes, patterns from 2 classes. And there are a lot of configuration options. So you can define the order of classes. You can define if you want or not the task labels. You can already define here the transformation you want to use both for the training data set and the evaluation test dataset that usually don't include the random data augmentation procedures. So there are a lot of configurations even for classic benchmarks. And this is the very simplest approach to the benchmarks module. Now, we choose to let's say model, those instances return from the classic benchmarks, and even from the tools you may use to create your custom benchmark. Those benchmark instances you obtain are a composition of streams. This is a choice we, let's say, consider the most general, the most unconstraining choice. And at the moment, those instances expose to two different data streams, which is the training data stream and test data stream. And each element in a stream is an experience. Consider an experience as a container for, well, first the PyTorch dataset that we carry your examples for that experience, possibly task labels, and even any benchmark specific metadata. So you get like a container for, let's say, data in general. And for the training stream, of course, this will mean that each experience will, let's say, describe, let's say, bring you the data you will be able to see only once. And of course, we have a different semantic for the test stream, which is very useful too. And we are planning on expanding the capabilities of Avalanche to support every possible custom stream. So validation streams, out of distribution streams, any possible arbitrary streams. So consider a benchmark instance as a container of those streams. And may seem, let's say, complicated, but this is the very simple. It's terribly simple. So we got a benchmark instance from the split-MNIST classic benchmark. We can obtain the training and test stream by just using the train stream and test stream fields, and we can iterate those streams to obtain the experiences. And it's easy to obtain the dataset attached to that experience, which is a PyTorch dataset. You can use data loader from PyTorch. You can use every possible tool already found inside PyTorch. And this dataset will contain patterns, okay? And that will be outputted along with the task label. But apart from that, streams not only can be used by iterating them. For instance, you may want to jump inside the test stream to test a different portion of the stream. You can use also, apart from iteration, also indexing and even slicing. So if we have a, let's say, class incremental scenario, we can obtain the cumulative test set by getting all the experiences from the up to the current, let's say, training experience. So it's very simple even to slice and index. You can do whatever you want. We don't force users to, let's say, follow a convention or things like that. Avalanche, we wanted Avalanche to be as simple as possible. You can do whatever you want with it. So feel free to implement your algorithm and do whatever you want with the benchmark module. This is the very basic loop you see expanded in the presentation from Antonio with the training part. So this is it. While classic benchmark are very good, you may want to implement your own custom benchmark or even port a benchmark you already wrote in the past months or years. And we offer two kind of APIs here, the higher level API, lower level API. If you are very lucky and your benchmark fits in a class or task incremental setting or in a kind of domain incremental setting, we offer utilities to help you in this process. So we have utilities that will allow you new classes. Utility will allow you to split your dataset or one or more data sets by creating experiences, each containing all patterns from a subset of classes. And the same goes for new instances for the domain incremental setting. So these are very useful utilities. And if you're lucky that your benchmark you want to implement fits into one of those cases, you are very lucky because it's very simple to use. I'll show you in the next slide. But if you want to implement more complex scenarios, which are less, let's say, known in the community, non-standard and things like that, you can also create those benchmark instances from a list of tensors, a list of files, cafe-style file lists, And even by creating a custom PyTorch datasets object and passing a list of those, each defining an experience. So we want to expand these tools to, let's say, provide tools to implement custom benchmarks, even if they are defined in very strange ways, and they are even if you need to define them in different ways that are not already covered by the list we already have of tools. And this is a way to use the new classes, let's say, helper method I already explained, which is the one used for creating a class and task incremental alike settings. We just, here in this code is very simple. The first 2 lines of code create an NNIST dataset instance, which is the one you can get from the Torch Vision package. It is exactly the Torch Vision one. You can pass it to the NC scenario helper. And there are a lot of configuration options here for the NC scenario. I show you only 2 of them, the most used of them, the number of experiences you want to obtain from it, and the availability of the incremental task label for each experience. So you can choose to include it or not, but you can also define the amount of classes for each experience, the order of classes. There are a lot of other configuration options, and the same goes for the new instance helper. So it's very simple to use. And if we want to have a look also to the lower level APIs, there are good collab examples and well, there is a lot of documentation on Avalanche. We are already working on improving it, but it's already very, very good. So consider having a look at it. And consider the aspects regarding names, let's say name of components and choices we wanted to, let's say, for Avalanche. We didn't enforce any kind of particular nomenclature. We try to keep things as much as independent with respect to the presence of task labels. So you won't find any, let's say, forced convention when using Avalanche. We want users to be able to do whatever they want with this tool. So you will not force to have a increasing task label or things like that. And at the same time, benchmarks creator are not forced to, let's say, have follow a particular predefined choice. Benchmark creator, in fact, can also define the task labels at pattern granularity when defining their experiences, but it's a choice that we leave to them. So the semantic of each experience, the training streams, test stream, and things like that are left to the creator of the benchmark. We don't force conventions here. And so this makes it very easy to create even complex scenarios in an easy way. And for the next, let's say, months, we wanted to implement, integrate new benchmarks. And I really appreciate we would like to see contributions from the community. And we already integrated many community contributions, Stream 51, Open Loris, and it is very easy to integrate even using the lower level API. In fact, for Stream 51, used a lower level API to implement it, thanks to Tyler Ayers that provided implementation. And we want to implement the ability to have custom streams. We have already nearly done the, let's say, support for regression, segmentation, in the future also for object detection. And of course, we want to expand the tools that you can use to define your custom benchmark. So if you want to port your custom benchmark to Avalanche, you receive a lot of support, and we can also create tools on the fly for you, and which is very good because you get to implement your benchmark inside Avalanche. That may boost the usage of your benchmark, and we want to support the community in this, even by creating ad hoc tools for Avalanche. So feel free to contribute, and Gabriele will explain how to do that at the end of this presentation. So thank you for your attention. I'll leave the stage to Antonio.
Thank you so much, Lorenzo. And it's really great to hear about benchmarks, and I'm glad that Avalanche makes it so easy, especially if you want multiple data sets and you don't have to go through anymore and to make all those standard plots where you're comparing all the different benchmarks and your algorithm efficiency to. You can just load them all in one swoop and you're done. But once you have your data, you probably want to do something with it, unless you just want to look at all the pretty MNIST digits. And so how can Avalanche help you train your algorithm? Antonio Carta from the University of Pisa is about to tell you.
Okay, can you hear me?
Yes.
Yes.
You can also see the screen. So,
absolutely.
Yep.
I'm Antonio Carta, and I'm the maintainer of the training module. And today I will give you a high-level overview of the training module and how we implemented continual learning strategies inside Avalanche. So Avalanche provides for you a set of popular strategies that are already implemented and ready to use, so that you can easily do your own experiments with them. And also defines a set of tools that you can use to define your own custom strategies. So it's easy to modify the basic training loop of Avalanche strategies to add custom behavior, to implement your own strategy, and also to add things like logging of the metrics or tensor board loggers that will be useful to track the performance of your strategy. At the higher level, it's really easy to use Avalanche strategies. You just have to initialize an object. For example, the replace strategy, you give it the model architecture, you give it the optimizer, the loss criterion, and then you give it the size of the buffer, and you are done. And then you have two different methods, one for training and one for evaluation. And this is all that you need to know if you just want to use Avalanche strategies. And then to use your model to training, you have a simple training and evaluation loop. For example, here you define a scenario, split needs with 5 experiences, and then you loop over the experiences in the training stream. And the experience inside the training stream, as Lorenzo already showed you, has everything that you need to train your model. So the idea of the experience, the classes inside the experience. So you can call the train method, passing the experience as an argument, to update your model and the internal state of your continual learning strategy. And this train method returns a dictionary with the metrics so that you can keep track of the performance of your model. And then once you have updated the model, you can call the eval method to evaluate your model on the test stream. And of course, since you have the ability to split the stream, you can call the evaluation method on a single experience of the test stream, on a cumulative test stream with the experience that is up to the moment where you are training, or with the entire test stream, like we are doing here in the example. And this is part of Avalanche flexibility. Also, the basic strategy work with independently of the specific scenario. So, for example, if you have a multitask scenario where you have task labels, but your strategy does not need task labels, the strategy still works by ignoring the task labels. So you don't need to worry about differences between these scenarios, because everything will just work when you are using your strategy. The training module is designed with two different components in mind. The basic component is the strategy. So the strategy defines a continual learning algorithm by defining two simple methods, the training and eval methods that I have just shown you. And then we have plugins. So plugins provide you a simple interface to add custom behavior to the training and evaluation loops. Basically, the plugins implement specific callback points that are called inside the training loop. so that you can provide custom behavior like a buffer for replay, or for example, the tracking of the metrics and logging, as you will see in the next talk. You can also add plugins to a basic strategy. For example, one thing that you can do is to create a hybrid strategy. Let's say that you want to combine a replay strategy and a regularization strategy. So you use the replay plugin, you set the memory size, and you have your replay plugin. Then you can set the EWC plugin, for example, with the EWC lambda regularization strength, and you have your regularization plugin. And then once you create the base strategy, you pass an additional argument, which is the list of plugins. And when you execute this strategy, you call the train method. Apart from the basic training loop, you will also have the replay and EWC callbacks. So you will have the memory buffer that will be automatically updated, and you will have the regularization with EWC. And this is a really nice feature because it allows you to combine different plugins or define additional feature for the training loop. And once you have these features defined as plugins, you can use them with all Avalanche strategies. So if you want to use the strategies already defined for you, it's extremely easy and you just need a couple of lines of code. But you can also use Avalanche to define custom strategies. And the easiest way to define a new strategy is to use a plugin. So you identify the points inside the training loop where you want to inject your code, and then you define a plugin that customizes only those specific callbacks. And this is the easiest way because you don't need to really interact much with the basic training loop, and you can do it with a small knowledge of the internals of the base strategy. But also you can implement custom strategies by overriding the base strategy. And you can do this by just overriding the methods of the training and evaluation loops directly. So why should you use Avalanche to implement your own strategies? Well, first of all, Avalanche strategies provide you automatic logging and metrics evaluation. And this is the kind of code that is easy to write, but may take a lot of time, and it's always the same. So having logging and evaluation already done for you saves you a lot of time. And also, apart from logging and metrics, most of the time, the basic training loop will be always the same. So by using Avalanche strategies, the end result is that you write less code, and you also have the advantage that you can easily share your own strategy with the community. So other people can test your strategy in their own specific scenarios. For example, so under the hood, the base strategies is the base class for all the continual learning strategies. And this provides a simple training loop, which is the basic loop without any continual learning specific, without any strategy specific several phases, data set adaptation phase.
I think that we lost Antonio, right? Or is
Was
just
that
me?
just me or is that everyone else? Yeah. Antonio, can you hear us?
Let's see if he can reconnect.
Oh, I see movement.
Antonio, I can see you now.
So when did you lose?
At the start of the base strategy slide.
Okay, sorry. The base strategy is the base class from which all the continual learning strategy inherit from. And the base strategy defines the main training loop for all the continual learning strategies. And this training loop is divided into different phases. For example, you have the dataset adaptation phase, you have the training epoch phase, training iteration, and so on. And custom strategies can override each of these methods to provide different code to define different strategies, of course. And then for each of these phases, you have the callback point, which you can identify by the prefix before and after. So by calling this callback point, you can inject code inside the basic training loop and use these points to define new strategies. And the base strategy also provides you with all the basic attributes that you need. For example, the dataset, the data loader, the current mini batch, and so on. So the internal state of the strategy is managed by the base strategy, and you can use it inside your own plugin. This is an example of a custom plugin. It's a experience replay plugin. So when you implement experience replay, you need two simple operations, at least for the basic experience replay. You need a method to update your buffer, and then you need a current training. And here you can see that this is exactly what the replay plugin is doing. So inside the constructor, you initialize the buffer, define the memory size, and then you have the after training exp method, which is called after each training experience. And this method will need to update the internal buffer. I didn't show you the code here because it's too long to fit in a slide, but you can go and look it inside the code base, and it's extremely easy to read and understand. And then you have the adapt train dataset that takes the current data taken from the current experience and concatenate the data with the data from the buffer. So just by defining these two methods, you have a replay strategy. Custom strategies by overriding base strategy methods. For instance, on the union of the experience to the
Antonio, we're starting to lose you again. You might restart the slide.
to do this, can you hear me now?
Yes, I think.
Okay. Okay.
No, I don't think we can hear you anymore.
Maybe Antonio, you can also switch off your camera to see if it's a bandwidth problem.
Okay, is it better now?
Yeah, try now.
Yeah.
Okay. So this is an example of a custom strategy. The strategy inherits from the base strategy, and it's a cumulative strategy, which means that you take all the experiences seen up to this point, and you concatenate the data from all the experiences. And you can do this by overriding a single method, which is adapt trains dataset. So you concatenate data from all the previous experience, and then you set the adapted dataset attribute of the base strategies. And then you are done. So you can define a custom strategies just by overriding a single method. So this is just a high-level overview of the training module. Just to give you an overview of what's coming next. First, we are working to implement many more strategies.
Well, Antonio, I think we lost.
Let's see how many.
We might just go ahead.
Okay, can you?
Yes.
This is just the slide module. First, we are working on implementing more strategies. Can you hear me? Or
yes, yes, now.
Okay.
Yes.
Okay. So if you're interested in a particular strategy, you can post an issue on Avalanche, or you can even implement it yourself. If you are interested, just contact us, and we will guide you and support you, of course, during the implementation. And another important issue is the support of different learning scenarios, such as continual reinforcement learning, which we are currently discussing internally, and we want to support in the future. And this is all from my side. Sorry for the bad connection.
No worries. Thank you so much, Antonio. We got through it. And I will say probably one of my favorite things about all of Avalanche is the plugins module, because I know how difficult it can be to take your existing code base and then when you want to add something to it, find some spaghetti code on GitHub or write your own and try and merge them together. And I don't know, the plugins module is beautiful. It just makes it so much easier. But once you have your custom module that you built to train, you probably want to do some science on it, and the best way to do that is metrics. And so to tell you all about them is Andrea Cossu at the University of Pisa.
Thank you, Keiland. So yeah, I'm in charge of the evaluation module. So how to keep track of your experiments and to see how they're going, which is quite an important part, of course, of continual learning, since we all know that there are many different aspects when it comes to evaluating the performance of your model. So basically, the evaluation module currently provides a set of metrics and a set of loggers to support you in the tracking of the experiments. So these things are already implemented for you. So we have a list of available metrics. I'm not showing you here all the metrics we support. You can and you should check out our documentation online, which is now updated and list all the metrics and all the features. But for sure, you will find many famous ones like accuracy, the forgetting, of course, but also other metrics concerning the amount of computation you are doing, the amount of resources that you are using. So our objective is to form a robust and complete idea of how your model is performing. And of course, if you are not satisfied with our metrics, you can create your own metric. So this is quite easy because, as Antonio already showed you, you can compose many different strategies by exploiting the plugin system, but you can also write new metrics by using the same plugin idea. So basically, you can inject new metrics within the training and evaluation loop and do whatever you want in that stage. So instead of writing the code of your metrics here and there in your code, you have just a single class that can act at different levels in the training and evaluation loops. So here I will talk about already implemented metrics because, of course, It's quite simple to use them, but do not forget that you can easily create other metrics anytime you want. The loggers are a separate way, a separate thing with respect to the metrics, because if the metrics targets a certain aspect of performance, the loggers target how we report this performance to the user. So the user can see these results in different ways, for example, through TensorBoard, or from a textual file, or from an interactive console output. So there are many different ways of logging things to the user, and we are starting to support different loggers. Currently we have 3, but I would say 4 in the near future, also with the weights and biases support. And all this stuff is supported through the evaluation plugin, which is, no surprise, a plugin again. So the concept of plugin is fundamental in Avalanche. The evaluation plugin basically orchestrates the metrics and the loggers. You don't have to do anything, because once you specify which metrics you want to use and which loggers you want to use, and we will see in a moment how to do that, the evaluation plugin is responsible for computing metrics, forwarding metric results to the loggers, showing you the output. It's all done internally. But of course, if you want a raw access to the metric results, because you want to do amazing plots by using amazing libraries that you know, you can always access a dictionary containing all the metrics recorded up to that point of the computation. So this should be also should also allow you to do custom logging if you don't want to use the default Avalanche loggers. So enough talking. This is the code. What does this code do? Basically, it tracks the metrics and log results to different output systems, and it's all contained in this amazing box, which is the evaluation plugin. So this is the main magic happening behind the curtains. So the first part, of course, you are just importing. So as you can see, the logging module and the evaluation module contains all that you need. Basically, the loggers that we currently support, the metrics, these are only a subset of the current metrics, because otherwise I would have had an awful number of lines of code. And the evaluation plugin, which is contained into the training module, because of course it is a plugin. So here we are instantiating the evaluation plugin, and how can we pass metrics to the evaluation plugin? Well, Avalanche already provides you with functions like accuracy metrics, loss metrics, which automatically create metrics at different levels. Okay, so accuracy metrics, you can specify mini batch equals true, means that after each mini batch, after each iteration, this metric will record the accuracy on that mini batch. And stream means that after the entire evaluation stream, so when you are evaluating your model, after the entire evaluation stream, you will get the average accuracy on all the experiences within the evaluation stream. So if you have a test stream composed of 5 experiences, like in split MNIST, the stream parameter here will report you the average accuracy on all the test experiences. And this is all you need to do to evaluate your code. You can pass an infinite, well, actually in theory, but a large number of metrics to this evaluation plugin. You can type many rows here, and at the end, all you have to do is, if you want, specify loggers, because otherwise, of course, you will see accumulated metrics. So the evaluation plugin will monitor the accuracy, the loss, the forgetting, the CPU usage. But if you don't specify loggers, there is no way the evaluation plugin can tell you, can show you the results of these metrics. So to specify loggers, you just add logger to the evaluation plugin. which is quite simple, as you can see here. So the text logger basically writes the output in a file. The interactive logger uses TQDM, which I guess many of you already knows, to interactively show the output. And TensorBoard logger, of course, logs metrics on TensorBoard, and you can access and navigate the TensorBoard interface as you already know how to do. But how, well, what do I do with the evaluation plugin? Because this is just an instance up to now. Well, I just pass the entire evaluation plugin instance to the strategy. So each strategy has an evaluator parameter, and you pass the eval plugin to the strategy. And that's it. Then when you are in the training loop or in the evaluation loop, as Antonio already showed you the code example before, you don't have to do anything because the evaluation plugin runs under the hood and automatically collects and logs all the results. So these are just the lines of code you need. But if you want, as I was saying before, to access all the metrics, well, the evaluation plugin automatically collects all the metrics in a dictionary. And so at any moment in time, you can call this get all metrics, which I guess the name is not surprising, returns you a dictionary with 2 lists for each metric. So the first list is the x values, so what in TensorBoard you will see in the x-axis, for example, of a plot. And the second list is the metric values, so values recorded on that x point. So it's very intuitive. And that's it. So this is how you can monitor your evaluation code. Please, your code. Please also check out the documentation because there are a few other things that you may want to look at. But just to show you an example of what is the interactive logger, this is a subset of what you will see in your console. Of course, I'm not able to show you TQDM on a slide. I don't have a video right now, but you can imagine that each epoch there is a progress bar growing for each mini batch you're processing, and then you see the output. So this is the epoch loss. So after epoch 0, you have this loss, 1 point something, computed on the train phase. So you are training your model on the train stream. So you passed to the strategy and to the continual learning algorithm the train stream of your dataset. And the task label is 0, okay? So this is the gist of it. And after the training phase ends, after the epochs, the evaluation phase starts, and you have the loss, for example, on the entire evaluation experience. And this is the eval phase on the test stream. You can also call the eval on the train stream, of course. And this would say eval phase train stream. Okay, so I think it's quite simple to understand this code. And at the end of the entire evaluation phase, there are maybe, if you added them, other stream metrics. So the entire loss, the average loss on the entire test stream is this number. Okay, and if you added also the TensorBoard logger, you will see these plots. Of course, these are done by TensorFlow. And as I was saying before, we will have very soon weights and bias also embedded in our loggers. Just a quick note, these metrics I just showed you are integrated in the training and evaluation loop. But of course, they are based on standalone classes. So if you want, we also provide you with simple classes like accuracy, loss, CPU usage, which you can use standalone in your code. Beware that these are not integrated. So you have to call the update function of the metric manually by passing the 2 tensors for in this case, for the accuracy. So you pass the real and the predicted outputs, and you can call metric.results, and you will have the accuracy, the average accuracy computed up to now. You can call result many times, and after calling update, and you will get always the total average accuracy until you call reset, which will reset the state of your metric. So this is something you may want to use if you don't want to use the automatic integration with training loop, but I would say that it is much easier if you just use this kind of helper functions in the evaluation plugin, because otherwise you have to insert this result call in your training code. But if you don't want to use Avalanche for your training, you can use these metrics as well. So for the future, the main thing, apart from adding new metrics, new loggers, this is an ongoing process, is to provide evaluation protocols. So we want to design a way to perform, for example, model selection with cross-validation in continual learning, evaluate multiple runs with different seeds. So this is something we want your feedback on this, basically, because cross-validation and model selection in continual learning is not something that we all agreed on. So I guess each one of you makes this in different ways. And so it will be interesting to see how different evaluation protocols we will be able to support, and we are working on it together with the training, of course, and the benchmark, because we need validation streams, of course, in this case. So this is the main future addition to Avalanche I would like to bring. So thank you very much for your attention, and I leave you with the next Avalanche module.
Thank you so much, Andrea, and I'm excited for the evaluation and loggers, particularly because now it makes it so easy for people to measure their continual learning algorithms on a host of metrics that they might not have done previously, just because it takes time and effort and you have to learn about what they are. And now it's as easy as just adding a new item to your list. And lastly, our last little segment to tell you about Avalanche is probably the most important, because it's how the community can get involved to help, and the model zoo that surrounds it. And so without further ado, Gabriele Graffieti from the University of Bologna will tell us.
Okay, can you hear me?
Yes.
Okay, perfect. Thank you, Keiland, for the nice introduction. Can you see my screen, the slides?
Yes.
Okay, perfect. So yeah, basically we saw the benchmark modules. So how to deal with the data. We see how to train a model. We see how to evaluate our training, our continual training, and how to log the metrics. But yeah, we didn't see what the models are in Avalanche. So just a brief a brief introduction to the model modules. Avalanche is based on PyTorch. It's built over PyTorch. So basically, we support all the PyTorch, Torch Vision, and PyTorch CV model. I don't know if you know PyTorch CV, but it's a very powerful library, and it contains, I think, hundreds of models. So I'm pretty sure that anyone can find a perfect model for their continual learning scenario or continual learning experiment. Apart from all this model, we also give to the user these four simple models. So we have a simple CNN, a simple MLP, the MobileNet V1, and a simple MLP trained with Tiny ImageNet. So basically, you can use every model you want that is contained in PyTorch, Torch Vision, or PyTorch CV. Now it's time to let you know how to contribute to Avalanche. If we convinced you that Avalanche is a really good library and a really good project, maybe you want to contribute to the project. As we said before, Avalanche is open to any contribution. It's of course an open source project, and it's open to contribution by any person. So how to become first an active Avalanche user? So first, I think we suggest to become familiar with all the Avalanche features. Vincenzo already showed you the Avalanche documentation here. Inside this documentation, there is a tutorial, so learn Avalanche in 5 minutes. So a really fast tutorial on Avalanche. So it takes only 5 minutes to learn all the library. If you want to go more in deep, there is the From Zero to Hero tutorial, which is a more detailed tutorial, and it basically explains all the different things that we showed you in this presentation. We also have the notebook that you can run on Google Colab. These notebooks are here in the From Zero to Hero tutorial, so you can watch them from the tutorial, or you can go to this GitHub repository where all the notebooks are contained. If you also want to consult the API doc, so you really want to learn how Avalanche works, you can consult the API doc following this link. How to become an active user, but first of all, if you don't understand something, or you want to give us a feedback, or maybe you want to discuss a new feature or a possible improvement of Avalanche, please join our Slack channel. We have a Slack channel called Avalanche in the ContinualAI Slack. Here's the link. Or you can open a discussion on GitHub. In the GitHub repository, there is a tab called Discussion, and you can open a new discussion, so discussing your new idea or your new feature proposal. Lastly, if you find an issue on Avalanche, so something that it doesn't work, or maybe you expect that it works in a way, but it works in another way, or every issue you can find on Avalanche, please open an issue on GitHub, so in the issue tab this time, and here's the link to the corresponding page. So after that, you have become an active user of Avalanche. Maybe you want to contribute to the project. To contribute, first of all, you have to install Avalanche in developer mode. What it means, it's simply a more, let's say, a bigger environment. So it contains more libraries and more Python packages for the development of Avalanche. This environment can be installed by hand following the guide in the Avalanche official documentation. I just leave the link here. Or if you work on Linux, you can use the install environment dev.sh script. You only have to pass the Python version that you want to install and the Conda version of your GPU. Or if you don't have a GPU, you can just say that you don't want to use CUDA, so it runs on CPU. After that, you have installed the Avalanche developer mode libraries. We want to keep track on the people working on Avalanche, basically because we don't want that 2 people at the same time are working on the same things. So we use the issue page to keep track of the work. So if you want to contribute to Avalanche, you can assign yourself to an open issue, and I suggest you the issue labeled as a good first issue, because they are a good starting point and for your first contribution to the library. Or maybe you can also submit a new feature request. For example, I want to add this new benchmark, or I want to expand the evaluation model with these new metrics. So you can propose a new contribution to Avalanche, and you can assign yourself to working on this new contribution. After that, you can do your magic here. Just some advices for working with Avalanche. So we work with GitHub and fork. So in order to contribute, you have to fork the official Avalanche repository. You have to push all the changes in your local fork. And only after that, you could ask the integration of your new feature or your contribution through a pull request. Please do not push directly to the official Avalanche repository, even if you have the permission to do so, because, well, we see it in two slides, because you have to pass through a pull request to give your contribution. Always remember to, well, this is some basic advices working with a team in GitHub, so and with Git. So pull offer from the original repository. There are many people that are currently working on Avalanche. So maybe at the same time you are working in your local copy in your new feature. Maybe another people already integrated their contribution to the main branch of the official Avalanche repository. So we want that you always have the more recent version of the code. So please pull offer for the original repository. Please add tests and examples usages for every new feature you develop and you insert. And try closing an issue within roughly 7 days. Of course, this is not mandatory. If an issue maybe it's too long or it's too difficult, you can always divide an issue in two or more sub-issues. Or maybe you can just comment in the issue, sorry guys, this takes more time than I preventivated, and I need to work more on this issue. No problem at all. Just keep in mind that after 7 days, we want to hear maybe at least a comment from from you and how the work is progressing. Another point is code quality. So Avalanche is, as we said before, is a project that it's an open project with a lot of contributors. So we want to maintain a code quality within all the project. So all the code submitted to Avalanche should comply with our quality rules, which are, well, we enforce PEP8 compliance. This shouldn't be a problem because the rules should be the same of PyCharm. So if you use PyCharm to develop your Python code, just make sure that you don't have any error or any warning in your in the PyCharm and it should be okay. You should comment every new piece of code you write. This doesn't mean that you can that you should comment every line of code. Just insert the API comments at the start of new classes that you write, or at the start of new modules or new functions. And you should provide unit tests for every new component you develop, because we want that almost everything inside Avalanche is tested and it works in every occasion. We force all these code quality check with GitHub Action, as we will see in a few minutes. So before open a pull request, make sure that all the checks in your local fork pass correctly. These are just a few commands that you could run in order to check if all the code quality checks are passed in your project. So, for example, you can run a pcode style, which is included in the Avalanche, which is it's a Python package that checks PEP8 basically, and it's included in the Avalanche development environment. So just run pcode style Avalanche, and for example, in this case, there are 2 errors here. In this file at line 44, expected 2 blank lines, found 1. And in this file, line 89, no new line at the end of file. So it lists all the PEP8 errors, so you can correct them. And for the test, you can run the test with this command. Use GPU false if you want to run the test on CPU. Just use GPU true if you have a GPU. Fast test equals true, sorry, or for faster testing without in-depth controlling. Just this command to make sure that all the tests pass correctly. If you also want to include the test coverage, so you want to know how much of the project is covered by test, just run this command here. It's basically the same. Instead, coverage run instead of Python here. Currently, the project has a 76% of test coverage, so make sure to increase it, or at least not decrease the test coverage. Lastly, why I said before that you should push your change in your local in your fork and integrate all the changes in a pull request, and do not push directly on the Avalanche main repo. Well, because every time you push in your fork or you open a pull request, we run all these checks and many more automatically using these GitHub actions here. So, for example, here is a screenshot of all the GitHub actions that are run in a pull request. So as you can see, many of them are passed correctly. One of them, so a unit test, failed. So if you before pushing to the or open a pull request, you see in your fork that something doesn't work or something failed, please correct it before open a pull request, or before merging a pull request, or before pushing directly to the main repository. Yeah, I think that's all for my part. I don't know, Vincenzo, if you want to say something more about the conclusion, or I can go, or maybe I can continue myself for the last 2 slides. I don't know, let me know.
Yes, you do that.
Okay, perfect. So, as you may have seen in our social accounts, so in I think Twitter and LinkedIn, we recently had a poll asking basically to all our users what they prefer to support next. So what is the next thing that we are likely to see integrated into Avalanche. I think this is the results on, I think this is Twitter. Correct me if I'm wrong. And it seems that the majority of people want PyTorch Lightning support within Avalanche. So this is the decision of the people. So I think we will start soon to work on PyTorch Lightning support on Avalanche. And I think on the 21st of April, we are invited to the PyTorch Ecosystem Day to present a poster about Avalanche, and we also want to enter the PyTorch ecosystem, so being supported and sponsored by PyTorch. So finger crossed about our proposal. And yeah, basically the 21st of April, we are presenting Avalanche to all the PyTorch ecosystem board. And yeah, I don't know if any people could join this event. I think yes. So just note the date and see you on the 21st of April for the Avalanche virtual and for the Avalanche poster at the PyTorch Ecosystem Day.
Awesome. Thank you so much, Gabriele. And I think that wraps up most of the talks. If folks want to stay after and ask questions for a brief discussion, they absolutely can. Or if they want to leave, they can also. Thanks, everyone.